Today, we're going to do topic 3.4, factoring and solving equations.
Yay. Putting the fun in function.
We are going to put the fun in function. Today, tomorrow, and Monday. We're going to do this section. Today, tomorrow, Monday. And what? Why? Because I said so. Why so long? Because there's a lot of stuff in this. Because we got factoring, we got to make sure we're experts at factoring again, because we've already been experts at factoring. And then we got to make sure that we know how to solve. And then, yeah, good stuff. Good stuff. Okay? And then Tuesday we're going to take a formative in the MRC. Well, we're not. You are. And then Wednesday we're going to take a quiz. Yeah, because I got to make the answer key. So, yeah. So. And then Thursday and Friday of next week, you're not going to be here.
You are.
I am.
Yeah, till like 7 p.m., right?
On what?
Till like 7.
On Thursday?
Yeah.
No, probably even later.
No, they did it till like 9.
Yeah, I'll probably be here till 9:30 probably on Thursday.
Why?
Volleyball.
That way you don't want to coach softball.
No, I don't want to coach softball because of the people. My last team, I had a really bad third baseman. She was just straight up mean to me. No, I can't. Spring's too busy.
He's an international harvester.
I am, but in the spring I'm an international planter.
Oh. He's an international
All right, so if memory serves me correct, and memory normally serves me correct, especially when I know what's coming up, there are 4 things that you need to remember about factor. Okay? Actually, there's 5, but we'll get to 4 of them today, and we'll do 1 of them tomorrow. Okay? The very first thing that you need to do is you need to look at your polynomial. Today we're just going to factor. Tomorrow we'll start with factoring, and then we'll get into some solving, and then Monday we'll finish up solving. Okay? But when we're factoring, what we've got to do first is we've got to look for the GCF. Okay? You've got to look to make sure that there's no term that can come out of any of those. Okay? So, because we're dealing with algebra, it's a 2-step process. Okay? So you first got to look at the numbers. Is there a number that goes into 8 and a 20? 2 and 4. Okay, so there's 2 of them that do it, that go into both of those. We want the greatest common factor, so we're going to go with 4. Okay, so we look at the numbers first, and then that's going to be 4. Then you got to look at the variables. This one has x squared, which really means it has 2 x's. This one is just x, which really means it's just 1x. So because they both have an x, this way, 2 and 1, right? I can take 1x out. If it were 8x cubed and plus 20x squared, I could take 2 x's out. Okay? But since it's only 20x, I can only take 1x out. Then that leaves me, now here's the most important part, I got to go back and I got to say, okay, if I take 4 x's out of 8x squared, I'm left with 2x. If I take 4 x's out of 20x, I'm left with plus 5. Okay? And that is the factored form of that one. Now, out of curiosity, how can I check my factoring to make sure that it is correct? What? You can multiply it out, right? I could redistribute that 4 4x into the problem. 4x times 2x is 8x squared. 4x times 5 is 20x. Okay? So we can actually do the math. Okay? So that's one of the things that we have to remember. Another one that we need to remember is the difference of perfect squares. The formula for the difference of perfect squares is a squared minus b squared is going to equal a minus b times a plus. Got to be a perfect square. Terms of numbers, what are some perfect square numbers? Well, let's start at the smallest. What's the smallest perfect square number? Nope. Smallest perfect square number. 1. Then 4. Then 9. Then 16. 25. 36, 49, 64, 81, 100, 121, 144, 169, 14 is 196, 225 is 15, 16 is 256, 17 is 289. 18 is 324. 19 is 361. 20 is 400. Okay. In terms of variables, what makes a variable a perfect square? Thought-provoking question. What makes a variable a perfect square? Is x squared a perfect square? Yeah. Is x cubed a perfect square?
Yes. No.
Yes or no? No. No. Is x to the fourth a perfect square? Yes. X to the fifth?
No.
X to the sixth?
Yes.
X to the seventh?
No.
X to the eighth?
Yes.
Yeah.
Every even number.
It's what?
Every even number.
What's even?
Exponent.
Exponent. Even exponents make a perfect square variable. Okay? Write that down. Even exponents make a perfect square variable. Okay? So with that being said, is 9x squared minus 1 the difference of two perfect squares? Is 9x squared a perfect square? Yes? Perfect square of what?
3x.
Of 3x. So this is really 3x times 3x. Is 1 a perfect square?
Yes.
Yes. Perfect square of 1. Is there a subtraction sign between the two? Yes, there has to be a subtraction sign. So my A value is 3x, my B value is 1, so this factors to be 3x minus 1 and 3x plus 1. The third thing that we have to remember is we have to remember the basic product of two binomials. So if you have a trinomial and you need to factor that trinomial, you yes, you are going to try and factor it using two binomials. Okay? Sometimes you'll hear us refer to this as the butt cheeks. Okay? All right? And really, there's no way other than guessing and checking. So what two numbers, the two numbers that multiply to be, or in those two spots, multiply together to be this number? What two numbers multiply together to be 2x squared? 2x and x.
Participating too.
Huh? The two ending numbers multiply together to be this number. What two numbers multiply together to be 20? 10 and 2. Okay? 5 and 4. Any other ones? 20 and 1. Okay, so we've got options there. Okay, we've got 20 and 1, 10 and 2, 5 and 4. Okay, I would always start in the middle. And then what you have to do, and you can do this, most of the time you're going to do this in your brain, is you're going to have to multiply those together. The outers and the inners. And so the outers give me 10x. The inners give me 4x. If I add those two together, I get 14x. If I subtract those two together, I get 6x. So I could either get plus or minus 14x, or I could get plus or minus 6x. Neither of which is 3x. So now I've got to reset. Well, but first I would try 5 and 4. Switch them around. Now my outers give me 8x. My inners give me 5x. If I add them together, I get 13x. If I subtract them, I get 3x. So I can either get plus or minus 13x or plus or minus 3x, which is what I need. I need a minus sign, so I need the bigger one. I need it to be negative 3x. So the big one needs to be negative, and the small one needs to be positive. And now we've got it in factored form. Okay. The last thing that you have to remember today is cubics, and we will get to cubics in about 16 minutes. Okay? Promise. I guessed 15 in the last class, and then it took us 16. We're going to go with 16. So let's factor these completely. Now, factoring completely means we can factor and factor and factor until we can't factor anymore. Okay? So we can't say that if we're going to Stevens Point, we can't say that we're in Stevens Point if I only made it to Rib Mountain. Okay? That's not factoring completely. If I just do one thing with factoring, and there's more things to do, I can't say that it's factored completely. So, first thing, always look for GCF. Is there a GCF between 98x and 14? What do you think about 14? 14 goes into 98 how many times? 7. So it factors to be that? It does. I promise. Did you put 2? You had 7? Oh, okay. So yours could have gone even further. Okay. Greatest common factor in number 2. 2x. What's left over?
6x cubed.
Nope.
And that's 6x squared. Plus 11x. Plus 4.
Now we got to look at the 6x squared plus 11x plus 4 just to see if it is factorable or not. The 2x comes along as that little fish that swims alongside the shark. I think they're called Emora fishes. Go along for the ride. The shark swims, creates a dead zone in the water, and this little fish just swim right along with it without ever expelling any energy. Okay. Factorable, not factorable. What multiplies together to be 6x squared? 6x and x, or
2x and 3x.
2x and 3x. What multiplies together to be 4? 2 and 2, or 4 and 1? Okay. So what do we want to try first? 2 and 2?
Sure.
Okay. If I do 2 and 2, I get 4x in the middle, 6x on the outsides. If I add them together, I get 10. If I subtract them, I get 2. Neither one is 11. Okay. So now we got to try 4 and 1. 4 on the outside or 4 on the inside? 4 on the inside. If I do 4 on the inside, I get 3x on the outside and 8x on the inside, which gives me 11. And then we would do what? Add them together. So when it's all said and done, 2x times 3x plus 4 times 2x plus 1. Okay. Try those two. Like eye boogers on extra crack, you know. All right, first one. Yay, nay on GCF. Is there a GCF? 5, just 5, that's it? 5G cubed. What's left over? G squared plus 16. Can I factor g squared plus 16? G squared is a perfect square. 16 is a perfect square. Can I factor it?
Yes.
Why not? Because it's plus, it's not minus. So I can't factor it anymore. Okay? It's difference of perfect squares, not sum and difference of perfect squares. Okay? Number 4, GCF. 3x. What's left over? 25x squared plus 10x plus 1. 25x squared plus 10x plus 1. Factorable, not factorable?
Not anymore.
Not anymore?
Right? Maybe I'm wrong. Oh,
Two numbers that multiply together to be 5x squared. 5x and 5x, right? Numbers that multiply together to be 1. 1 and 1. Plus and plus.
no, I wasn't ready for this.
Right? 5x plus 5x is 10x.
Okay.
Linsmeyer throwing us curveballs all the time.
Okay, we're right.
Could I also rewrite this one as 3x times the quantity 5x plus 1 squared? Okay. Love it. Go for it. GCF. 3x. What's left over? X to the 4th minus 13x squared plus 36. Is that trinomial factorable? Two numbers that multiply together to be 36 and add to be negative 13. What? But what is it? 9 and 4?
I just am so sick of
Yes?
Yes.
Are either of those factorable? Which one? Both of them are. Because both of them are perfect squares minus perfect squares. What's up, Stone? What was the point of what?
That.
This?
Yeah.
So that tomorrow when I say, well, let's solve this one, you can easily solve this one and say that the 5 zeros of this one are 0, 2, negative 2, 3, and negative 3. Whereas if you just go up from here, you're like, From there, you just set each factor equal to 0.
I hope you got that on recording.
I did. They can hear you, yes.
Can they hear me?
They can hear you, yes. See this thing right over here next to my computer? Kaylee, this thing right here, that's called a microphone. Yeah.
Crazy.
Point it out
Yeah.
to capture
I
sound.
know you can hear me. I say stupid things all the time.
Yes! Alright, so I promised you 17 minutes ago that I'd get to this slide in 16 minutes. So here we go.
Wow.
Okay.
Let us down.
I think it was 16. It was pretty close to 16. Okay. So those are the cubic formulas. Okay. They are also in your book. I think it's on page 354 maybe in your book, I want to say. Okay. But don't necessarily memorize the exactitude of everything, of all of these formulas. Memorize the pattern.
Helps if you got it right side up, by the way.
Yep, 354 in your textbook. Okay? You're good. I got you. The pattern is this. Okay? So you got cube and a cube. You got two cubes. Okay? You take the uncubed part, so just the A, and this one, this first sign is the same as what's in your problem. The second sign is opposite. And the third sign is always plus. Okay. So you take them, A and B, you square A, you square B. That's your bookends. And then you multiply A and B in the middle. Okay. So, let's do one to make it less confusing. (27x cubed). Is that a perfect cube? Yes? What's it a perfect cube of? 27x cubed is a perfect cube of 3? Or a perfect cube of 3x? It's a perfect cube of 3x. (125). Is that a perfect cube? Of what? 5. Okay? So, the pattern would go 3x and 5, because that's what I'm cubing to get A cubed and B cubed. Since it's plus, it's going to be plus right there. Then I take 3x and I square it. 3x times 3x is 9x squared. I take 5 and I square it. That's 25. I take 3x and 5 and I multiply them together and I get 15x. First sign is the same. Second sign is opposite. Third sign is always plus. Now, the nice thing about the cubic formula is that trinomial that comes as the second part of it is unfactorable. Try that one. I know. I am the meanest math teacher you have today.
Yeah.
I'm also the meanest math teacher you had yesterday.
Yeah. And I even do math and physics and in AP. Haha.
I know, but they're science teachers and social science teachers.
He doesn't know how to use a calculator.
What do we GCF?
2D squared.
2D squared?
Yes, sir.
Anybody GCF anything different? I'm going to GCF a negative 2D squared.
There you go.
What's left over then?
Why'd you do negative?
What's left over then? 8D cubed minus 1. What? Is it factorable? You can, but then you got extra negative signs all over the place. No.
No.
Yes.
No.
Yeah, you actually do. I'll show you when I get done. Okay? 8D cubed, is that a perfect cube? Of
Yes.
what?
2.
2D.
2D.
1 perfect cube
Yes.
of
One.
1. Okay? So the negative 2d squared comes along. Inside the first set of parentheses is what? Inside the second set of parentheses is what? Four d squared plus 2d plus 1.
Yeah.
The second part?
Yeah.
You have to square. You got to square that one. Right?
Okay.
So that's 4d squared. You got to square this one. That's 1. And then you got to multiply these two together.
2D.
Pattern. Okay? You, young lady, before had said, what if I did this way? So you factored out a 2d squared, then that left you with negative 8d cubed plus 1, right? Okay, so then yours would have factored to 2d squared, negative 2d plus 1, 4d squared, then it would have been minus there, right? Negative 2d plus 1. Okay, but you more than likely you would have forgotten the plus part, changing that to a plus part.
Alright, fair.
Okay, right? Plus you got this extra
Oh god.
negative right there. Plus then this is, positive. It's all Katie Wampus. Okay. So much homework tonight. Yes. Before you complain, actually look and see how many problems I gave you tonight. Yesterday?
Yeah.
I gave you an entire mod to work yesterday.
That's fun.
Yeah, because I gave you 20 minutes in class to work. Yeah. Whether or not you chose to use those 20 minutes is not part of me,
You definitely didn't hear a word out of me. I wasn't saying anything. I was grinding.
I know. The middle class was grinding so much they were putting me to sleep because it was so quiet in here.